Howdy howdy, this is KK4YDR again, making a new video on the usefulness of active vertical antennas running through a DX engineering phaser, the NCC-1, and I am going to show you the difference between what most people might hear in a noisy environment and what this box can do to help people. Essentially what you're looking at here is 75 meters. I've got the VFO on the Flex 6300 here. I've got my Flex 6300 and I've got the VFO. I'm only running one pan adapter right now, and as you can see, it is awful. Look at the noise. Look at that right there across the band. That's not static crashes or nothing. That is some wide-banded noise, and I think the culprit may be my electric fence or a power pole. I'm not quite sure, but it doesn't matter, because in some heavier urban, I live in the country, but in some heavier urban, more dense environments, you're going to see all kinds of QRM and all kinds of man-made noise and all kinds of just crap that you cannot alleviate. You can't do anything about short of complaining, and even then you're lucky if you find resolve. But there is a resolution. Is running active vertical antennas, which of course I can't show you on this video because it's dark outside and they're about 300 foot away from the shack here. I've got two of them out in the field, and they work together as a team to phase, counterphase noise, and do all kinds of cool little things. The box itself up here has a phase controller, and based on the normal and reverse switch, it's actually capable of 360 degrees of phasing noise signals. It has a balance control, which is between antenna A and antenna B, which are separated by about 80 feet apart from each other. I can null antennas down to 30 dB below and essentially turn that antenna off. I can also reverse between A and B and actually reverse, so A is on this knob and B is on this knob essentially. I can also run low and high bands, which have to do with the way that the active vertical circuitry recognizes frequencies and passes them onto the box. From the box, there's a category, sorry, not a category 5 cable, I'm thinking Ethernet, but from the box there's a coaxial cable, 75 ohm, that runs into the transverter port. That's by my decision, because the transverter port is not capable of transmitting more than a few milliwatts of RF, thus defeating any chance of destroying circuitry in the box by accidental transmission. There is also a VNC connector, sorry, not VNC, RCA connector in that box, that whenever I key up my radio, it essentially flips a relay in there and powers down the actives in real time. It also, in that there shunts any RF current to ground instead of coming back up to the box. So if my high power transmit antenna decides to put a 1500 watt signal out on the air, and somehow the actives receive that signal and a high amount of energy comes back up the coax into the NCC-1 and into my radio, it will not fry any circuitry, because that RF is then shunted to ground out there at the actual antennas. Moving along, here we have this noise. This noise is abhorrent. It's awful. I'm going to go ahead and turn up the AF on my speaker here. I want you to take note of my pan adapter. There are some QSOs behind this noise. What if those QSOs were a net you wanted to participate in, or this was a contest and you wanted to work those stations, or those are your good friends that you want to talk to, but you can't because when you dial in, this is what you hear. So there's apparently a conversation behind there. And of course there's somebody tuning up an amplifier on top of them. So let's just move it out of here. Let's go to this one over here. Looks like it's probably around 3812, I'm guessing, maybe 3813, somewhere around there. Okay, so what we're going to do is we're going to try the typical radio, even the powerful flex radio. We're going to go ahead and we're going to put in an attenuator. Okay, the attenuator, you can see it knocked the signal down quite a bit, but the attenuator knocks all signals down quite a bit, including the noise. Let's go ahead and throw some DSP in there. So we'll turn on noise reduction. We'll even go as far to, so we'll say we'll put it about 25-ish%, and we'll even run some noise blocker. We'll adjust the AGC to compensate a little bit. Somewhere about right up in there, I guess. Now let's listen.
Oh, sorry, I said it still looks like an upside down apron.
Yeah, most people could work that. Say, yeah, I could do that. But looking at the pan adapter, look at the amount of noise. Look at these pulses. Look at that. And there's still that QSO is buried in that noise. Now that's where your friends are talking, right? You want to get on there and talk to these guys. But man, imagine sitting here and having to listen to this for 3 hours while you talk to these guys in a rag tube. I couldn't do it.
Hey, Bob.
So let's go ahead. We'll turn these features back off. We'll turn the DSP off. We'll turn the noise blinker off. Okay. And we'll adjust the AGC again. All right. Now, running all this noise on here. Let's go ahead and switch on the NCC-1. And we'll adjust my AGC. The NCC-1 does notably reduce signals quite a bit, but it does enhance the signal-to-noise ratio. Look at that, complete reduction in noise. And let me turn the attenuator off.
The sharp point of your pelvis bone in your back, it's like,
I'm still getting a couple pulses in there, but we can tune those out with the old NCC-1 here.
Get up, and then it's hard really to walk, and it really gets bad. The longer you're sat, why the worse it is when you stand up and walk. But it hurts more in your back than it does in your hip itself.
Yeah, okay, well, I don't know. I know it's been aggravating me for about 4 or 5 days or a week or more.
When they look at, they scan that.
There we go. A complete nullification of that abhorrent pulsing noise and the complete ability to hear a QSO.
Nothing there.
Look at that pan adapter.
Oh, God.
Alright, let's go ahead and turn off the NCC-1, go back to the
Calcium pills by the bar.
vertical antenna.
I don't think I take pills.
I didn't think so. We're drinking
Listen
milk
to
right
that.
now.
And that's $1,400 well spent. if that's what you want to do to build a dedicated receive system, there you go. That's what it takes. I'm sorry, but no amount of DSPing, noise blanking, any of that can reduce that noise. I'm sorry, it's just not going to happen. You can build different antennas that reduce noise. You can go to a loop. I'd show you my loop antenna, but not for this video as we're already approaching 10 minutes. But in the meantime, I just wanted to show you how noise phasing works. It's an amazing system. And if you haven't tried one yourself, one day, I think that one day you ought to. I think it's worth it. Okay, that's the end of the video. You guys have a wonderful day.